Good evening, everybody. I'm here with my good friend Kevin, and we're going to help you go through the basics of finding the area of a circle. So in last night's video, we talked about the properties of a circle. We talked about the definition being all of the points that happen to be equal distance from a single point. That equal distance turns out to end up giving us the radius, how far it is from the middle of the circle out to the edge. And we also learned that we have lines that cut across circles from one edge to the other called chords, and that the longest chord is the one that goes right through the middle, and that's called the diameter.
Yep.
Since the diameter goes from one side to the center to the other side, it's exactly double the length of the radius. And so we have all those basic facts and descriptions of a circle. Okay, so now we also talked about circumference, and now we're going to kind of continue on with what we finished that video with, and we're going to talk specifically just about the area of a circle. Now, I gave you a formula yesterday, and I said that the area is equal to pi, the Greek letter that represents the mathematical constant, about 3.1415926, you know how it goes, times the radius to the second power, so the radius times the radius. So what I thought would be really good today is show you where that formula comes from. So what we're going to do is we're going to take a circle here, and we're going to cut it up into, imagine this is like a pizza, and let's cut it up, in this case, it looks like we're cutting it into 10 pieces. And what we're going to do is kind of like when we found the area formula for a parallelogram. We cut off the little diagonal part that was sticking out. We took it and we moved it over the other side. We glued it on and we turned it into a rectangle. Then we could use the rectangle formula to come up with the formula for the parallelogram. Okay? Well, we're going to do the same kind of thing here. And it's a little bit weirder because when we cut the pizza up, we get these kind of rounded edges down here on the bottom. But go with me for a second, and I'll kind of explain how this is going to work. So what we're going to do is we're going to arrange the pieces like so, where we're going to put every other piece upside down. And you can see that pretty much it starts to look kind of like a parallelogram. Okay? The only thing is, down here on the bottom, it's a little bumpy. And same thing up here on the top. Okay? Well, all right, so right now when we only cut the pizza into 10 pieces, it's a little bumpy. But what if we cut them into 20 pieces? Or 30 pieces, or 100 pieces. The more pieces we cut them into, the less bumpy this little curvy part is going to be, and the more like an actual parallelogram it's going to be. So, and that's exactly true. If we cut it into small enough pieces, it'll basically act just like a parallelogram. All right, so let's take what we know about parallelograms. All right, so we'll do this in blue. The area of a parallelogram is its base times the height. Yep. All right. Well, the height is pretty easy. I want you to look at the red line that was the radius over here, and the height here. Basically, for any piece of the pizza, the radius is going to be the same. So these heights are all really just the radius. Okay, so as we derive the formula, we're going to try to turn the blue formula into the red formula. All right, so we got area equals, well, right away the height is equal to r.
Oh.
Okay? The height of the parallelogram is the same as the radius of the circle.
And the base would be equal to the circumference.
Well, the base is a little bit weird. Yeah, the base, let's look at the base really carefully. All the curved part, all the way around the outside, basically makes this top part here and this bottom part here. So if I know the circumference, and I take half of that, we'll just say, up here it says 1/2 c. Let's take c over 2. Okay? That is basically the base of the parallelogram.
Yeah.
All right, now let's use what we learned yesterday in the video. We learned that the circumference is the pi times the diameter.
Yeah.
But we also learned another formula for it. We learned that circumference is 2 pi r, because the 2 and the r, if you multiply 2 times the radius, we just talked about that.
Diameter.
That's the diameter. Right. So if I put this right here in for the circumference, I get 2 pi r, that's the circumference, divided by 2 times r. All right, one more line. The 2's are going to cancel out. All right, 2 divided by 2 is just 1, and 1 times pi times r gives me pi r. R is pi r squared, and we have just derived the formula for the area of a circle. Now, I don't know whether this is the way mathematicians of old actually came up with this formula, or whether this is just an explanation as to why the formula works. I suspect it's probably a little bit of both. But in any case, this kind of explains the formula pi r squared. Okay, so let's go ahead and let's practice using this formula on a couple real circles. Okay, again, remember that the diameter is the distance across the circle, and the radius is the distance from the center of the circle out to the edge.
Yeah.
And that the relationship between these two, a diameter is always equal to twice the radius. Okay? All right, so let's go ahead and actually put some numbers in here. So let's say that the radius here is 5 feet. Okay, let's say this is a big circle that's been drawn on a driveway or maybe a basketball court. And so it's got a radius of 5 feet. So all I have to do to find the area of the circle is take the formula pi times radius squared, and I just put 5 in for r. So I'm going to get 5 squared. Now remember, 5 squared does not mean 10. It means 5 times 5, and 5 times 5 is 25. Now what we usually do with pi, just like with variables, even though pi is technically a number, a lot of times we'll put the number in front and then the pi here. And that is my exact answer, and it would be some sort of unit squared. I think in this case I said feet, so let's go ahead and fix that. Let's make it feet squared.
Yep.
Okay? The biggest mistake that people make when they're doing areas of circle is they forget that 5, right here, that 5 to the second power means 5 times 5, not 10. Okay? So just be really careful about that, and you shouldn't have too much trouble. Okay? Now, there's another type of problem that sometimes they'll give you, and that is, instead of telling you that the radius is 5, sometimes they'll be sneaky, and they'll tell you the diameter of the circle is 10 feet. Well, then what you need to do is you need to remember the diameter is twice the radius, so you first need to stop and think, okay, wait a second. If the diameter is 10 feet, the radius must be what?
5 feet.
Yeah, 5 feet.
That's easy.
Okay, and by the way, for those of you listening to the recording, Grace has joined us for the second half, so she's going to be tagging along too. All right, so let's, how about you guys help me out with this one? How do I find the area of the circle down here? Again, let's start with the formula. And by the way, this is the way I want you to show your work on your page. Okay. It's good practice to just write down the formula. It only takes a couple seconds. And then from that formula, you can show how you're plugging stuff in. Okay, so what do we do for this one?
So you find the diameter, and it's 14 feet.
Well, it would be 14 feet, but do I need to even bother doing that? What do I have right here? What's 7?
Oh, you have the radius, and so a...
Yeah, we already have the radius. So this is not a sneaky one. So I just take the radius and do what?
You, what did I say? Right. You times it by 2. You square it.
You square it. You don't times it by 2. You times it by itself. You take it to the second power. So 7 times 7 is 49 times pi. And this one was in meters, so we'll say the answer is in meters squared, and that is the final answer. All right, so that's really all there is to it. So if they try to get sneaky on you and they tell you that the diameter is something, no big deal. Just take half of it and find the radius. If they give you the radius, then you just square it and you leave it like that. Now, you could put in 3.1415, something like that, in a calculator, and you could get an approximate answer. But the problem is when you do that, you have to round.
Yeah.
Because pi is a really super long number, never ends, so you won't ever be able to get the exact answer. So actually, math teachers usually like it, unless they say specifically round to the nearest whole number or round to the nearest tenth, like you to leave it in terms of pi. And I'm one of those math teachers. So unless the directions for a problem that you're working on say to round, leave it in terms of pi. All right? So let's do a couple more of these. Why don't you guys go ahead and pause the video here. I'll get you started. You're going to start each of these problems by writing a equals pi r squared. Okay? And just pause the video for a second. It should just take a second. And find the area of these two circles. And as soon as you have, resume the recording and see if you agree with what we came up with.
Yep.
Okay, so let's look at the first one here. Okay, Grace, what do I need to do with this one?
You need to square 3.
Right, take the radius right here, 3, and put it in and square it. So we get pi times 3 squared, which is going to give me what?
9.
9 pi. And what was my unit?
Inches.
Inches, and since we're doing area, it'll be inches squared. And that is the right answer. Okay, Kevin, what do we do over here on the second one?
I find the radius by turning that into half of it, so 4.
Okay.
And 4 squared is 16.
So put 4 in here for the radius, not 8, because you have to take half first and square it. 4 squared is 16. Good.
Pi centimeters squared.
Excellent. That's exactly right. So 16 pi centimeters squared is the area. That's it. That's all there is. That's all it takes, guys.
Right.
So don't make these harder than they are. So let's. I played around with my little circle maker. So we'll wrap up with that's all, folks. That's all. And thanks for watching. And we'll practice these in class tomorrow.
Bye.
Bye.